Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Hello dear students, I hope you're all doing well. Welcome to another video from the Easy Chemistry for All. I'm Mr. Muad and we will be going through a new lesson today inshallah. But before we continue, please share and subscribe to the channel. Share it with your friends, with your within your groups on social media, so that many students can hopefully benefit from these videos. Okay, so we are in our Inspired Chemistry series. We are starting in module 5 lesson 2, which is titled Classification of Elements. So last time in lesson 1 we talked about the periodic table, right? We learned about the periodic table and elements and how scientists helped in creating it. Okay, today we are going to learn how to classify elements within the periodic table. Okay, so after this lesson, you should be able to explain why elements in the same group have similar properties, like group 1, group 2, group 7, so on, and identify the 4 blocks of the periodic table based on their electron configuration. Okay, so the periodic table can be divided into 4 blocks, which we will see together inshallah throughout this PowerPoint presentation. All right. Okay, so part 1 is focused on classifying elements based on their electron notation. So of course you know electron notation from module 4 lesson 3. The 1s2, 2s2, 2p6 and so on. Okay, that's the electron notation. All right. Okay, let's go to the keywords. So the periodic table, you know the periodic table, chemical elements organized based on atomic numbers. You know what's a group in the periodic table. They are the columns, and you know the period, which are the rows, right? Okay, so can I ask how many groups exist in the periodic table? Very easy, right? From 1 to 18, so 18 groups. And how many periods are there in the periodic table? So 1, 2, 3, 4, 5, 6, 7. So 7 periods, okay? It's very important to remember these things. All right, so this is the main idea or the focus question of this lesson. Why do elements in the same group have similar properties? For example, if we go to group 18, which are noble gases, why are noble gases chemically inert, or they are not very active? They are inactive, right? They are stable, very stable. Why is that? Why are group 1 elements very reactive, or group 2 elements very reactive? Okay, why do elements in group 17 have similar chemical properties? Okay, this is what we are going to try and answer throughout this video. Okay, so let's try an investigation, guys. Okay, I want you to write down the electron notation for the following atoms: lithium with 3 electrons, carbon with 6 electrons, neon with 10 electrons, and scandium with 21 electrons. Okay, now you can stop the video and write down the electron notation for each one of them. Okay, and after you write that, I want you to write the highest energy level, okay, which is the valence shell or valence energy level, the highest N, right? And then the number of valence electrons, which we discussed in module 4 lesson 3, and the last filled subshell or sublevel. Okay, what do I mean by this? Let's see an example. Okay, this is the order of filling, if you remember, just to help you. And for example, oxygen has 8 electrons, right? So this is the electron notation: 1s2, 2s2, 2p4, or 1s2, 2s2, 2p4, right? The valence shell or the highest energy level is N equal to, which is here, right? The number of valence electrons is 2 plus 4, which is 6. And the last sublevel or subshell is P, as you can see here, right? It's the last letter. So I want you to do the same thing for lithium, carbon, neon, and scandium. You can stop the video here and come back when you finish. Okay, so hopefully you were able to draw the electron notation for lithium, carbon, neon, and scandium. They are here. You can check your solution. Okay. Now, what about the valence shell or valence energy level? Here it's 2. Here it's 2. Here it's 2. And here it is 4. Right? This is the valence energy level. Okay. What about the number of valence electrons? 1. And here 2. Sorry, 2 and 2, 4. And here 6 and 2 is 8. And here we have 2. And what's the last subshell? For lithium it's S. For C it is P. For Ne it's P. And for scandium it's D, the last filled subshell, right? Now you would be thinking, Mister, what's the use of this? The use of this is that we can find out where are the elements in the periodic table using the electron notation. So let's look at lithium here. This is the valence shell, right? It's number 2. Let's look at lithium. Lithium is actually in period 2. So the valence shell gives us the row or the period in the periodic table. How many valence electrons are in lithium? 1. So automatically lithium will be in group 1. Look at lithium, it's in group 1. Alright? Same thing here for carbon. Carbon's valence shell is 2, so carbon is in row 2. Let's look at period. So carbon is in period 2, guys, right? Now, the valence electrons for carbon are 4, and the group is 14. Okay, we'll see why we added 10 to it. Okay, so we added 4 plus 10 gives me 14. Okay, so keep that in mind. And neon is in period 2 because the valence shell is 2. Okay, 2, and here's neon, it's also 2. And the number of valence electrons are 8. So 6 plus 2 is 8. And the group is, if we add 10, the group is 18. So you can see here it's group 18. All right? Now, you will see the blocks here. I wrote blocks in here. Okay? So the last subshell, okay, gives me blocks in the periodic table. So this is the periodic table, okay? If we look at the periodic table, we can see that it's divided into blocks. This is the S block, this is the D block, this is the P block, and this is the F block. What do we mean by that? We mean that the electron notation for all the elements in the P block will end with P. So here's neon, here's carbon, okay? And if we look, you will see that neon and carbon, they have P at the end. So because they have P at the end, they belong to block P. All right? Yeah. So we can know which row, which group, and which block in the periodic table just from the electron notation. And that's what we were focusing on in this part. Classify elements based on their electron notation. By classifying, we mean which group, which period, and which block in the periodic table. All right? So that's what we are focusing on here, guys. Okay? Now, there are some things here, okay, which we are going to discuss. For example, this plus 10, okay? And that's this thing. in here. It's explained in this slide. So how to find the group number for an element from its valence electrons. So if the number of valence electrons is 1, the group number will be 1. Valence electron 1, the group is number 1. Number of valence electrons is 2, so the group number will be automatically 2. Now starting from number 3, if the valence electrons is 3, we need to add 10 to it to find the group number. So if it's 4, we need to add 10 to it, and it will be group 14. And we saw that with carbon, right? See, carbon has 4 valence electrons. So to find the group, it's in group 14, we need to add 10 plus 4. Okay? 5, same thing, add, and 6 also add, and 7 also add 10, and 8 also add 10. And we saw that with neon. So neon has 8 valence electrons. Now we added 10 to it, and now we have the group number. Okay? Now this is true only for S and P block elements. What do I mean by that? I mean all the elements in S block and in P block. Alright? Now you notice that we didn't talk about scandium here. Right? So scandium has a valence shell of 4, so it's in period 4. As you can see here, period 4, here is scandium. But which group it is at? It's group 3. So, if we go back here, you might think, Mister, why didn't we, because it has 2 valence electrons, it should be 2 plus 10, and it should be in group, it should be in group 2, right? Because we said that if you have 2 valence electrons, you will be in group 2, right? But that's only true if the electron notation ends with S or P. Let's look at the electron notation for scandium. It ends with D. So we cannot use this rule. ما نقدر نستخدم، لازم النهاية تكون يا إما S يا إما P عشان نقدر نستخدم هذه العلاقة ما بين الفالنس electrons والجروب number. Okay, what about D? What should we use? So to calculate, to know the group of transition metals of block D, يعني تنتهي علامتهم بالD. Let me just remove this. We need to add the valence electrons plus the electrons in the D. For example, look at scandium here. The number of valence electrons is 2, right? So 2 plus the electrons in the D, 1. So it is 3. So automatically, scandium is in group 3. And that's what you see here. Tamam? That's only if your electron notation ends with D. If it does not, if it ends with P or S, then you can use this relationship automatically. Okay? So here's an example. The electron notation for oxygen is 1, S2, 2s2, 2p4. So because this is the highest shell or the highest energy level, then oxygen is in the second period of the periodic table. Okay? And the electron notation for oxygen is this one. So because it ends with P, so oxygen belongs to block P in the periodic table, this block, which is here. Now oxygen is actually in group 16. So how can we know it's in group 16? How many valence electrons are there? So 2 and 4. So 2 plus 4 equals 6 valence electrons, right? And it ends with P. So what was the rule? If I have 6 valence electrons, I just add 10 to it and I'll get the group number. And oxygen is in group 16. Can you see? Because it will be, so the group will be 6 plus 10, which is 16. Okay, guys? So this is how we classify elements. This is how we know the location of elements in the periodic table using their electron notation. Okay? So now, I want you to try, okay, and do this activity by yourself. So without looking at the periodic table, in which period, group, and block would you find aluminum? So without looking here, okay, using the electron notation. So the first thing, draw the electron notation for aluminum. We have 13 electrons. This is the order, if you remember, SS, dips, dips, to help you remember the order. So stop the video here, try to do it by yourself, and then come back and check. So the electron notation is 1s2, 2s2, 2p6, okay, 3s2, 3p1. So you know that to find the period we need the valence energy level, right? And to find the group we need the valence electrons, right? And to know the block we need the last sublevel or subshell اللي هي S, P or D or F. What's the easiest thing you can know from here? The last subshell. So it's in block P. Okay? Now what about the number of valence, or what's the period? So look at the valence shell. This is the highest N, right? This is the highest N. So the period is going to be 3. And the group is going to be the number of valence electrons, right? So 1 and 2, these are the number of valence electrons. 1 plus 2 equals 3. So the group will be 3. So do you think it's in group 3? Okay. It's not in group 3. Because the number of valence electrons is 3, right? So remember the table. If we have 3 valence electrons, we should add 10. So it would be 3 plus 10 equals 13. Let's check our solution. Aluminum. So period 3, keep going. And it is in group 13. And all of this is block P. As you can see here, here's aluminum. Group 13, period 3, block P. Okay, guys? So, if you did not understand, you can repeat the video. And what you can do, you can practice on your own. For example, take calcium. Try to draw its electron notation, for example, right? 3s2, 3p6, 4s2, and then check if it belongs to period 4. So this is the highest energy level, so it's period 4. Number of valence electrons is 2, so it's in group 2. Why? Because we said if you have valence electrons, 2 valence electrons, you just use it as the group number directly. And it's in block S because this is the S. It ends with S. So it's in block S, as you can see here. Okay, guys, so you can practice as much as you need and as much as you want. All right? Okay. So now we go to the second part of this lesson. And the second part is actually from module 4, lesson 3. Okay? You remember we have orbital diagrams and we have electron notation. We have actually something else. We have something called noble gas notations. So this was in module 4, lesson 3, but I did not explain it because I want us to study the periodic table first, because we need the periodic table, okay? So we will learn electron configuration using noble gas notations, okay? So, as you know, we call this one up here the orbital diagram or the orbital notation. And down here we call this the electron notation, right? We have something else called noble gas notation, which uses noble gases. okay, in the explanation, in the notation itself. So this is group 18. These are the noble gases لو تتذكرون من lesson 1. This is from module 5 lesson 1. Alright? So what are the steps to write down the noble gas notation? Okay? What are these steps? So for example, find the element in the periodic table. For example, if I ask you, draw the noble gas notation. So maybe right is better for, let's see here, magnesium. So find the elements in the periodic table. So where is magnesium, guys? It's here, right? Now find the noble gas. The next step, find the noble gas from group 18 that comes before it. So magnesium, the one that comes after it is argon, but the one that comes before it is neon, because this is 12 and neon is 10. Okay, so it's neon. Start writing the noble gas symbol between brackets. So we'll put neon here between brackets. Okay. Write the subshell S starting with the period at which your element is in. So I'll write Ne and then S. I will continue the electron notation now. الحين بكمل electron notation. Now Mg is in which period? It's in 3s, right? So 3s. تمام? Now Mg has 12 electrons, right? When we wrote Ne, Ne actually has 10 electrons. So it's like I used 10 electrons here. كأني استخدمت 10 إلكترونات هنا. كم باقي لي عشان أوصل ل 12؟ باقي لي 2 بس. So 3s2. So the noble gas notation is going to be 3s2. Why? Because if you look at Mg here, if we draw the electron notation for Mg, it's 1s2, 2s2, 2p6, 3s2. صح؟ And if we write down the noble gas notation for neon, neon عندها 10 إلكترونات, it will be 1s2, 2s2, 2p6. Look at these parts. They are the same, right? So instead of writing Mg like this, we'll just remove this part and we put Ne. So it will be Ne, and we continue with this 3s2. This is the electron notation for Mg. يعني كأنها نعوض هاي كلها بالNe. ليش؟ لأن الNe عندها نفس الإلكترون نوتيشن لهذا الجزء. فنحط الNe and I'm left with 3s2. And if you follow these steps, it will automatically give you this one. Okay? All right. So this is the example that we just did here, explained in here. All right? So write down the noble gas notation for the following elements. So we already did magnesium. Let's do calcium. So what was the first step? The first step, find the location for calcium. So it's in period 4, right? Then find the noble gas that comes before it. What's the noble gas that comes before Ca? It is Ar. الAr تيجي قبل Ca في periodic table, صح؟ إذا رجعنا للخلف. إذا رجعنا للخلف بنوصل للAr. So we will write Ar. And then I told you, just write S. Start with S. El calcium is in which period? It's in period 4, right? So you write 4s. Now argon has 18 electrons. يعني already احنا استخدمنا 18 الكترون هنا. الكالسيوم فيه 20. أنا استخدمت 18. كم باقي عشان أوصل ل 20؟ 2. So 2. Let's take something else. For example, let's take Cl. Okay, so let's draw the one for Cl. Okay, so what is the noble gas notation of Cl? Look at the period. Cl is in period 3, and the noble gas that comes before it is Ne. So draw Ne here and put S, right? And it's in period 3, Cl, فنحط 3. Now I used 10 electrons here, right? So because I used 10 electrons and the Cl has 17 electrons, right? So again, neon has 10 electrons and chlorine has 17. So I used 10, so I still have 7 more. So I'll just continue. 3s, 2. What comes after 3s in the electron notation? 3p, 5, and that's it. So it is Ne, 3s2, 3p5. Alright? Okay. So you can practice on writing noble gas notations. Like you can choose whatever element you want and then draw it and then, write it down. And yeah, you can check your solutions online. Alright. So, which of these words we should put here? Something notations can be used to shorten writing electron configuration notations. So, instead of writing 1s2, 2s2, 2p6, 3s2, 3p5, we just said Ne, 3s2, 3p5. This was for chlorine, الصفحة اللي طافت, the last page, remember? So what did we use here? This is electron notation, and this is noble gas notation. So which one is shorter? Which one makes it short? So of course it will be noble gas notation, right? Or this word. So nitrogen has an atomic number of 7. Nitrogen noble gas notation is He, 2s2, 2p3. So how many valence electrons does nitrogen have in 2s and 2p? So 2 and 3. If you add them, you have 5. An element has a noble gas notation of this. Identify the element. So we already know that. We know it's Cl, right? Because we wrote it just now. So this is neon, okay? And this is the last part of the notation. So of course you know that neon has 10 electrons and here 7. So in total 17, right? And the number of valence electrons in all of them is 7. Okay, so 17 electrons. Which one has 17 electrons here? It is Cl. Right? So, what is the noble? We already did aluminum and we did chlorine. The noble gas notation for aluminum is actually Ne, 3s2, 3p1. And for chlorine, it's Ne, 3s2, 3p5. Sorry. And for argon, Ar, it's going to be Ne, because Ne comes before Ar, and it will be 3s2, 3p6, because here I have 10 and I have to put 8 here, and that's the number of electrons in argon, 18. Right, guys? Okay, so now let's use the noble gas notation to try and find the location of an element in the periodic table. So here it says strontium, which is used to produce red fireworks. It has the symbol Sr, has an electron configuration or a noble gas notation of Kr5s2. without using the periodic table, determine the group, period, and block of strontium. Okay? So this is what's given to us, the electron configuration, and this is actually the noble gas notation, right? And they want the group, period, and block. So we have a look at Kr5s2. So remember the rules of noble gas notation. We always said that this number here is going to be the period because it's the highest number here, right? So the period is going to be period 5. Now, this is the highest period, so this is the number of valence electrons. And we said that if the number of valence electrons is 2, that means the group is going to be also 2, right? And then the block is the last letter here. So it's going to be block S. And that's it. Super easy, right? So if we go here, it's going to be group 2, period 5, block S. And here's strontium. So it's in group 2, it's in period 5, and it's in block S, right? Okay. So now, this is the periodic table divided into metals, metalloids, and nonmetals, which we saw in module 5, lesson 1. So the metals are mainly in groups 1 to 12. So all the red ones are metals. Okay, group 1 are alkali metals, group 2 alkali earth metals, group 3 to 12, and sometimes the 13 are called transition metals. Okay, and now we are going to go and look at the properties of the S block. Okay, the S block elements that end with S, right? So the S block elements consist of groups 1 and 2 plus the element helium, He from group 18. Okay? Group 1 elements have a partially filled s orbital with 1 electron, meaning that group 1 elements will always end with ns1. So n is the period. It can be period 1, period 2, period 3, period 4, period 5, and so on. That's what partially filled means. It means you can only put 1 here. Now group 2 elements have completely filled s orbital with 2 electrons, meaning it's like ns2. And as I told you, n is the number of the period, the energy level. Okay? So this is the electron configuration and how it ends. Where did we see that? We saw that here when we did strontium, remember? So it ends with S2, right? And it's in group 2. So it belongs to the S block. Okay? So why is helium in the S block? Okay? Although it's in group 18. So if we look at helium, it has 2 electrons. What's the electron notation? 1s2. Because the electron notation ends with S, so it belongs to block S. Okay? That's the reason why. Now, if we go to block P, you will notice that block P spans from groups 13 to 18 in the periodic table. من group 13 إلى group 18 في periodic table, and they have they end with the p orbital. Okay? So in group 18, both s and p orbitals of the period's principal energy level are completely filled. What does that mean? It means in group 18, they end with ns2, np6. يعني ال s orbital وال p orbitals are full. Okay? And this is the electron notation for block P. So they always have ns2. كل الgroups have ns2 in it. Okay? ns2, ns2. Now from group 13, it has p1, this one p2, this one p3, this one p4, this one p5, and this one p6. That's the meaning of from 1 to 6. So starting from group 13, you have 1 electron in the p sublevel or orbital, and as you keep moving to the right, you'll keep adding 1 electron because the number of electrons increase, okay, or increases. All right? As easy as that. Now, if we go to block D in the periodic table, which is also called the transition metals, it is the largest block. It has most of the elements. Okay, it's the largest block in the periodic table, and usually they have filled outermost s orbitals, okay, and partially filled d orbitals, except for some elements like Cu and Cr, if you remember in module 4 lesson 3, okay, the exceptions where you take an electron from 4s and you put it in 3d, okay. So you have 5d orbitals and they can hold 10 electrons because we have 5 rooms and each room can hold 2 electrons. So in total the d orbitals can hold 10 electrons, and the d block spans 10 groups in the periodic table. The p orbital can hold 6 electrons, right? So that's why the p block spans 6 groups, and so on. Okay, so same ideology or same analogy. Okay, so for example, scandium, which is here, has the noble gas notation of 4s2 3d1. So the d block elements notation always ends with ns and n-1d. What does that mean? If you have 4s, then you will have 3d. If you have 5s, you will have 4d. If you have 6s, you will have 5d. Always this number is less than this number by 1. That's what we mean, okay? And the d can be from 1 to 10, and the s is usually 2, okay? Takes 2. So that's the ending of the notation, like here. It ends with d, so it's in block D, okay? Now the final block is called the F block, and it has the inner transition metals, the lanthanides and the actinides, as we saw in module 5 lesson 1. The F block elements have filled or partially filled outermost s orbitals and are filled with partially 4f and 5f orbitals. So what does that mean? It means that you have 4f and 5f orbitals, and that's the ending of the electron notation. So if you see one of these at the end of the notation, then the element belongs to block F. Okay, now you know that the F can take 14 electrons because we have 7 orbitals in it. So you will notice that there are 14 columns here. Okay, so the block F from 1 to 14, because the F can take up to 14 electrons. Okay, yeah, and yeah, that's the end of the lesson. Let's go and work out some questions here. So what consists of elements with one valence electron? So if you have one valence electron, what does that tell you about the element? Where is it? Where is it in the periodic table? Is it in period 1? Is it in period 7? Or is it group 7? Or it's group 1? Remember, we said valence electrons, they will give you groups, right? So automatically, you should remove these answers. Now remember, if you have one electron, one valence electron, that's automatically group 1, right? And that's why we choose group 1. All right? So, for elements in groups 13 to 18, the number of valence electrons is 10 less than their group number, 10 more than their group number, and so on. Remember when I told you the valence electrons and the group? I told you if you have one valence electron, you are in group 1. If you have 2 valence electrons, you are in group 2. If you have 3, you are in group 13. So starting from 3, you start adding 10. 4, 14, 5, 15, 6, 16, 7, 17, and 8, group 18. So they are telling you these groups, okay? To get the number of the valence electrons, what should we do to these numbers? To go from here to here? We should remove 10, right? So that's why the answer is 10 less than their group number. العكس، احنا اللي كنا ندرسها انه الفالنس الكترونز نزود 10 عشان نحصل الجروب، صح؟ هنا هو يقول لك عشان اروح من الجروب للفالنس الكترون شو لازم اسوي؟ لازم اسوي العكس. To go from the group to the valence electrons, I need to subtract 10, right? In which block is group 17 on the periodic table? So you know from groups 13 to 18, you are in block P, right? We saw it in the previous slides. Which block on the periodic table has the most elements or the largest? We talked about it. It is the D block. All right? Very good. So that's the end, guys. I hope that you had or that you understood the questions, that this lesson is easy for you. If you have any questions or anything, please contact me. Also, don't forget to share and subscribe to the channel. And I wish you all the best and see you in the next video, inshallah. Take care.